interesting experiment. This is my very favorite experiment. I mean, it's kind of a prayer for me. So whenever I do science experiments, whenever I start my session, I start with this experiment. I learned this from Mr. Arvind Gupta in Bangalore. So I met him in Bangalore. He showed me this toy. I was shocked when I saw this experiment because till then I was thinking about science means laboratory, glass apparatus, chemicals, all those things. So first time when I met Mr. Gupta, he just showed me a straw and then he made a lot of toys out of it, and it was like brilliant. Just a straw, we drink a lot of juices and then we use it in everyday life, and then after we drink we just put it in dustbin. But he showed a lot of toys which you can make it at home, and these are wonderful things. And I'll show you one by one. You can follow me. People who have straws in front of you, please take a straw, and then if you have a scissors, take scissors. Kids who are younger, who can't use scissors, please take your parents' help. Let's start. So take a straw, and then what you have to do is very simple. At one side of the straw, you just need to make a pencil cut. It will look like a pencil, sharp pencil. See, can you see it? So this much you have to cut. Many of you are following. Good to see you. Just this much. It should look like a pencil, right? So now our toy is ready. Just keep it in your mouth and blow it. Interesting, isn't it? Just a straw, and you just made two cuts, and it works like flute. It works like a musical instrument. And I learned it from Arvind Gupta. It was very hard to stop it. We were adults, like we were 20, 30 adults, and we were playing with this for 20, 30 minutes continuously. We couldn't stop because first time we saw some science experiment with just a straw. Listen to the sound. When the straw is longer, this much, see how does it make noise? Now I'm going to cut the straw shorter and shorter. See when I cut, what happens. Did you hear music from it? Sarigama. All those things you can make out of this small straw. And then if you want to make animal sounds, you can make out of it. If you want to make baby sound, you can make out of it. See, I'm going to cry like a baby. You can cry like a baby. You can create sound like an ambulance. You can make sound like rickshaw. You can do a lot of things with this single straw. It sounds like a toy, right? Even adults enjoy the straw. It sounds like a straw. I mean, it's a small toy, but you can learn a lot of science with this straw. Now we'll see one by one. People who have newspaper, just take a piece of newspaper like this, only this much, half a A4 size. Yes, quickly cut it. Okay, people are cutting paper. We'll wait for them. Okay, just this much. Okay, so after we cut the paper, we have to make a cone out of it, just like this. Right? So if you have a tape, you can stick it, or you can just hold it. Take some tape. People who are trying these things for the first time, it'll take some time. What you have to do is, like, keep it in your mouth, here, keep your lips here, just press a little bit with your lips, and then keep trying. It'll take few times, and then if you try 10, 15 times, you'll get it. So now stick your cone with tape, just like this, right? Now I want to put the straw inside this cone. Cut a little bit so you can put the straw, right? Put the straw inside the cone and then blow it. When I blow it outside, listen to the sound. When I blow it inside, listen to the sound. Isn't it the sound increasing? It gets louder when I use the cone. Did you notice? See, when I'm blowing without cone, the volume is less. It is softer. But when I put it in the cone, see, it is louder. This is called amplitude of sound. So when you blow or when you make sound, it goes, sound waves goes like this. So if the length of the sound wave is shorter, you hear the sound softer. When you hear a louder noise, their sound waves will be longer. So when I use the cone, here you see the space is very little. So initially the sound wave travels very little. As the cone size getting bigger and bigger, the sound wave, length of the sound wave increases. So automatically the volume increases, so you hear it louder. This is called amplitude of sound. Okay, many of you are trying this thing, but you're facing difficulty while blowing. It's very simple. See, here you keep your mouth, keep your lips here, and then press little bit. Could you blow it? If you can blow it, show me thumbs up. Could you do it? Very good. I see thumbs up. See, keep your lips here, press little bit, and then blow. Could you blow it? Okay, I can see thumbs up. Thank you. So let's see what happens when you blow it. So I will show you the other side of the straw. So I'm going to suck the air from the other side. You can see what happens to the tip. See, I'm going to suck the air. See what happens. Earlier I was blowing like this, right? Now I'm going to suck the air. So you can look at the tip and see what happens. Okay, I'm coming more closer. Did you notice? So when I blow, actually the tips vibrate with each other. They vibrate with each other. That's why it creates sound. So basically sound is produced because of vibration. So when you clap, your hand vibrates. When you play musical instruments, some part of the musical instrument vibrate, like guitar, the string vibrates. If you play tabla, the skin which is on the tabla vibrates. When you play drums, the rubber sheet which is on the drum vibrates. When you even talk, your vocal cord, your throat vibrates. Can you keep your hand in your throat? Say something, or say like Om. Say Om and see what happens. Keep your hand here and then say something. Say Om. Om. You can feel the vibration. So it is because. Okay, somebody is asking how to cut. I'm showing it again. By the time you all practice blowing the straw, right? Others, if you have something like a speaker or a musical instrument next to you, just play it and touch and see, feel the vibration. Sound produced because of vibration. Same way our toy also works. Okay, somebody asked how to cut. I'm showing it again. Take the straw, just press little bit here, and then make a cut in the right hand side. Similarly, make a cut in the left hand side. Can you see? It'll look like A. I mean, ulta V. See? Can you see it? Right? Now, before you blow, if you're giving it to a small child, you cannot press quickly and blow. So press a little bit with your thumb and pointer, press a little bit and give it to the child. Tell the child to press a little, very little, not to bite. Press a little bit with the lips and he can blow. Right? How does it work? It works because of vibration. When you blow, the tip vibrates and that creates noise. Perfect. So we're going to make one more toy, uh, which works in the similar way. For that, you need a water bottle and then a balloon and then an old sketch pen. I think some of you may have, because I mentioned in the list. If you have all these things, okay, somebody's asking something. Okay, so you have water bottle, balloon, and then straw. If you have it in front of me, take it, keep it ready. So we're going to do an experiment with this. Okay. So when you have this straw, a longer straw, we saw the sound is like different. When it is shorter, the sound is different, right? This is because of the pitch of the sound. When the straw is longer, it creates high pitch. It creates low pitch sound. So you hear the sound like this. When the straw is shorter, it creates high pitch sound. Feel the difference? This is low pitch. This is high pitch. So this is not just a toy. It teaches us a lot of science. Even children who are in 6th standard, 7th standard, 9th, 10th standard who are studying in NCERT, they have lessons in their book, pitch, wavelength, and then amplitude. All these things are in their lesson. So when they learn those lessons, if they learn it with these toys, it will be great. They can remember well, understand well. Okay. So are you ready with the bottle, balloon, and sketch pen? Let's start. I'm going to cut the bottle. So if you have adults with you, just ask them to help you. Don't use cutter on your own. It's not safe. And anyway, like we are going to do a lot of experiments where we are going to use safety pins, cutters, scissors. So sit with an adult and try these experiments. Don't try to use those things. They are sharp. They can be dangerous. Okay. Take the bottle and then cut only the top portion. I don't want the whole bottle. Cut only the top portion. Okay, done. Okay, so let's cut it and shape it well. Okay, does it look like a funnel? Okay, so this is what we need. Then take the balloon, cover the bottle's mouth with the balloon. See, just like this. Cover the bottle's mouth with the balloon. This is setup, right? So now, time to use the sketch pen. One side of the balloon, at the bottom of the balloon, make a small hole. Just cut it and then see, I have made a small hole. You can open it now. And it's a little sticky. Okay, now let's put the sketch pen inside the hole. See, and then we may need a little tape to stick this so that air will not escape. Can you see? I put the sketch pen inside the hole and the balloon is connected to the bottle. This is the setup. Okay, now take some little tape, stick the balloon with the sketch pen. Done. Could you see clearly? Sketch pen is stuck with the balloon, one side of the balloon. Other side of the balloon is attached with the bottle. Right? Now, toy is completely ready. What you have to do is just pull the sketch pen so that here the balloon is stretched completely. Can you see? The balloon is stretched completely and then you have the sketch pen in your hand. Just pull it and then blow it. Is it interesting? Look what happens at the bottom. When I blow, this side of the balloon is stretched already, right? So the whole thing is, okay, the whole thing is stretched here. So now air cannot escape. When I blow, air cannot escape because this thing is stretched. There's no way to escape. So when I blow it harder, here the air pressure increases. That air pressure just push the balloon, make it vibrates, and then escapes through this. So when the balloon is uh, vibrated, that creates noise, just like our straw flute. So when you blow, this thing vibrate and then creates noise, right? Same way here, the balloon vibrates and then it creates noise. So if you stretch it more, the sound will increase, equal to a bus horn, right? It can be even louder if I stretch it more. Or if I stretch it less, like look at mummy's face. If mummy's face is normal, then you can stretch it more and then make it louder. If mummy already has headache and she's like little tensed, then don't blow it hard, blow it only this much. Okay, this also works with the help of air pressure and vibration. Okay, so now someone asked, can I make this flute with a thicker straw? I have thicker straws. See, I even have bigger size straws, and I have even this straw. See this one. So we can make the flute with these straws, but the problem is, as it is, as it is thicker, the vibration will not happen much because no, it is tight. If you do it with a smaller straw, this is flexible, so the vibration will happen more. Then it will create much noise than this. For children, I request use this because they can't blow harder straws. They need more energy. The lung capacity should be more. For adults, I mean, try it once and then see how hard it is. This one will be easier. So the thickness matters, the length matters. So what I mean is, like, you try with everything. Science experiment is not to follow somebody. Science experiment is to do it on your own and understand. Observe things, what happens, how it happens, and then learn it on your own. Use a longer straw, shorter straw, thicker straw, thinner straw. Use as many as possible materials, and then find out on your own which works better and where do you need more practice. Perfect. So let's make the next toy. Okay, for this toy, you need straw again. I'm going to use these two straws. Take a little bigger straw and then take one thinner straw. See, these are the two straws I'm going to use, right? Take your scissor. Have your scissor with you? Okay, take scissors, and then I'm going to cut this bigger straw into two pieces. See, one should be short and one should be longer. This much. This one is longer and this one is shorter. So we'll use the shorter straw later, keep it away. And we're going to work with this longer straw. What you have to do is take a scissors and I'm going to cut till this much. Leave a little bit and then cut this much. I'm going to cut it into 4 equal parts, right? I'm going to cut here, 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 here. So this straw will be divided into 4 parts. Let's start. Be very careful. All the 4 parts should be equal. Okay, one is done. I'm measuring. I'm going to cut it equally. Okay. Now cut this side. Done. So I have divided the straw into two parts. Let's make the third one. Third one is also done. Let's make the fourth one. Perfect. See, the straw is divided into four parts. Just bend them. See, it look like a flower. Look like a fan flower. I can see many of you are following. I'll wait for you. I'll show you closer. Can you see? Done? Perfect. I can see you. Yes, yes, I can see you. Thanks. So now cut the straw into four parts. Done. Now you may need a safety pin. Right now, if you don't have safety pin, it's okay. Right? So you can use this U pin. Have something to make a stand. See, just like this, so that it can hold this thing. Right? So I'm going to put it inside the straw, and then let's push it. Okay. Now our fan is ready. Right? Looks like a small flower. Now what you have to do is twist the fan little to your right hand side. Twist all four petals to your right hand side. Just twist it very little. Okay, don't often them. Okay, did you twist it? Ready? So now I want to show safety pin also, how safety pin works. Just take the safety pin, measure the height, make a hole, and then close it. Done. Right. So here, this thing is not strong, right? So let's fold it and then use the other part of the straw. This is not necessary, but if you make it, it will be easy for the children to hold. It will be strong. See, the toy is ready now. Okay. So now what you have to do is, if you're sitting outside of your house, I mean in the corridor or something, just blow it and see what happens. Blow it and see. Or if you're sitting inside the house, just keep it under the fan and you're done. Keep it under the fan. You don't need battery, you don't need wires, you don't need motor. Your fan will keep spinning, keep spinning, keep spinning. If you have a potato, just cut the potato into two half, place it on the table, poke this fan inside potato and leave it on this table. See, you don't need to do anything, no battery, no motor, it will keep spinning. And if you make 4, 5 and keep it on the table, it'll be very attractive. And guests, when you get guests, not now in lockdown, after lockdown gets over, when your friends visit your house, your relatives come to your house, it'll be amazing to see a lot of fans on the table keep rotating. Whenever your fan is on, this will rotate. You don't need to do anything else, right? Children who are studying about windmills, children who are studying about wind energy, this is the best toy to start with, and it will help them to understand. So it keep spinning. Let's for some time let be on the table. Let keep spinning. Okay, let's go to the next toy. So I have asked you to get some glass and cardboard and all those things. So please take it in your hand. So I'm going to use this glass. Take a small glass, and if you have cardboard, cut the cardboard in square shape. So this card should cover the glass exactly. So these are the two things you need, plus you need water also. So ask someone to get water, right? Let's start. Okay. Okay, I'm going to keep the fan down. Let it spin for longer time. Done. So take, someone is asking safety pin or U pin. You can use both. If you have safety pin, it's better. It will always remain same. If you have U pins, then that also you can use. But if the child pushes the U pin, it may fall sometime. Safety pins are best. If you don't have safety pin, then use U pin. No worries. Or if you don't have both, just use your thumb. Just put it on your thumb. Only thing you have to keep holding it. Just place your nail next to the straw and it'll keep spinning. Done? Thanks. Okay, so let's go to the straw thing. Straw, you need a glass and a cardboard. Take some water, pour it in the glass, full glass of water, and then cover the glass with this cardboard. Turn it upside down. I've not put any glue, no Fevistick, no Fevicol, no sellotape, just the cardboard over the glass. Someone is getting glass and cardboard. Okay. Now I'm going to take the left hand off. Let's see what happens. We expect the glass and the cardboard will fall, right? No, it's not falling. It's kind of magic. If you have friends, relatives visiting your house, if you want to entertain them, these are the magic, items you can show them. So no glue. I just put the card over the glass. Now it is stuck. It will not fall. The water will not come down. If you want to take more risk, instead of water, take oil, milk, coffee, tea, juice, and see what happens. Okay, this works because of air pressure. Air is applying pressure on everything, right? So it is applying pressure on the glass also, it is applying pressure on the card also, right? But only thing here, the glass is closed. So air cannot go inside, there's no pressure inside. But outside, there is a lot of pressure. That pressure is acting on the card, so the card is not falling. We can't see it, it's invisible, but the pressure is applying on the card. Pressure is pushing the card upwards, that's why the card is not falling. I can see many people are thinking that this is a familiar experiment, right? You must have done it in school. So I'm going to show a similar experiment, and that will be more fun and scary. Let's see. For that, you need a glass jar, right? And then you need a net kind of material. You can take mosquito net or something like this. This I got it from my sports pant, where I used to go jogging. That pant had some net like this, so I cut it and took it. So this net we need. You can see my face, right, through this net, which means there are a lot of holes in the net, right? Now let's cover the jar with the net, and then we have to put some rubber band to close it. Put a rubber band over the net and then stretch it. Now see, the net is covered the glass, right? Now if I pour water, will it go inside? Yes, of course it will go inside. Now I'm going to pour water. See, it goes freely inside because there are a lot of holes, lot of holes, lot of holes. Okay, let's pour some more water so that the glass will be full. Okay, it's full now. I'm going to do the same thing. Take a piece of chart, cardboard, cover the glass with the cardboard, turn it upside down. So now you all know, right? If I take off my hand, what will happen? The card will not fall down. Yes, you're right. The card is not falling. See, the card is stuck to the glass. What is more interesting with this thing is you can even take out the card. Wait, just a minute. Card was a little smaller. I'm going to take a bigger card. Let's pour it again. Quickly. The glass is full now. Let's take the cardboard. Piece of chart. Cover it. Take it upside down. Then slowly let's remove the card. See, the bottle is full now. There is no card, nothing is there, only the net. There are a lot of holes, but water is not coming out. I can even poke, no, I can even poke a stick inside. See, still it's not coming. Whenever you shake the bottle, water will come out. Whenever you hold it steady, it will not come down. Let's go more water. My hands are a little shaking. I think I'm nervous. Okay. I'm just worried about the electricity, that's all. Okay, done. Let's remove it carefully. Okay, see, I'm going to poke a stick inside through the hole. See, little bit water is coming out. The stick went inside. See, even the stick is going inside, but you can see the water is still up there. It's not coming down. It's because of surface tension. See, can you see the water? It's because of surface tension. When I shake it, the water comes down. But if I hold it straight, water stays inside. It's because of surface tension. Let me tell you what is surface tension. Water is made up of molecules. You know that, right? Water is made up of molecule. When you pour water inside, the top layer of the water molecules hold their hands and make a bond. So when they hold their hands and they make a bond, so they make a layer kind of thing over the water. So when you hold it upside down, the whole weight of the water works on the layer, so the layer breaks and the water comes down. But when you use a net or when you keep a card, the card and the net supports the layer, so that layer holds the water coming out of the bottle, so water doesn't come. It stays inside. This is because of surface tension. Right. So I'm going to show you some more thing with surface tension. For that, let's take a glass again. I think some of you may have, yes, I can see. Perfect. Who is that? Sunil Desai. See that? He put up. Can I make it bigger? Okay, I could see. Yeah, there's a net and a glass. He's holding it, but it's not coming down. Very good. Good job. Okay. Okay, this is also a simple experiment. We need a glass of water, right? Take a plate and a box. Right. Take a glass of water, right? And you may have coins also, right? I have mentioned it in the list. If you have coins, take some coins and keep it ready with in your hand, right? Pour a lot of water inside the glass. The glass should be full, right? The glass is completely full now. Let me show you. See, the glass is completely full, right? Could you see it? So now the question is, can we add anything to the glass? Can we add anything more to the glass? Will it go inside? If I add anything more to the glass, the water will overflow, right? Because there is no place for anything else because the glass is completely full. But I'm going to put some coins inside and see what is going to happen, right? Have full glass of water and I'm going to add coins to it, right? Let's count the coins. I'll show you how much water is there. See, it's full now. Let me add coins. I have added one coin, but still the water didn't overflow. Second coin, water didn't overflow. Third, perfect. Fourth, nothing happened. Fifth, coin went inside, nothing happened. I'm going to add the sixth coin and see what happens. Six, Nothing happened. Seventh, nothing happened. Eighth, oh, for the eighth coin, water came out. But we poured full glass of water, right? And then we added 7 coins. When the glass is full, when water is full, I mean, water is inside the glass is full. How could I add more coins to it? See, this much coin I added. 7 coins I added. How was it possible? This is also because of surface tension. If you watch the glass closely, let me show you. I think you can see it clearly. If you watch the glass closely, you can see the water is like a dome over the glass, right? It makes a curved shape over the glass. If you add more water, the water just raises up and then makes a dome. It doesn't overflow. It can make the dome up to some limit because surface tension hold the water towards the glass. I told you, right? Water molecules hold their hands and make a bond. So that layer holds the water from overflowing, so it stays over the glass. When I add more glass, when more water raises up, then the layer breaks, the bonding breaks, so the water overflows. This is because of surface tension. Perfect. Okay, let's go to the next toy. I asked you to get liquid soap. Do you have liquid soap with you? If you have liquid soap with you, take it in your hand. We are going to do an experiment with liquid soap. Perfect. Take liquid soap with you. And then take a small dish or a container. Okay. Perfect. Right. Now, it may or may not work with hand wash soap. It will not work, much with hand wash soap. If you have this liquid soap, which your mother uses to clean vessels, that will work better. If you have hand wash, use it and try it. Like, see what happens. Okay, take liquid soap and then pour it in the container. Don't do this in front of your mother; she'll get a shock because she uses very little for washing vessels. They have taken this much, 3-4 spoons of liquid soap. Add some water, little bit water. Then this is called glycerin. This is available in medical shop. If your father goes out, he can get it because the medical shops are open now, right? If you don't have, don't worry, don't take too much risk. If you have it, if you can buy it, buy it. Otherwise, use only liquid soap. That's fine. I'm going to add a little bit glycerin to it. Okay. Let's mix both. You have a stick or with your finger, mix them both. Okay. I think the solution is ready. Perfect. Now, take a water bottle and cut it this much. If you're not ready with water bottle, it's okay. You can do it later. I'll just show you what you have to do. Or if you have straw with you, you can try this with straw. If you have water bottle, you can do it later. See, I have a water bottle and I have cut the bottom out. So I don't need the bottom. I have a bottle like this. Okay. Now our toy is ready. So just dip the water bottle in the water, the solution, then blow it. Okay. Could you see the bubbles? The solution will take a little bit, little more time. So you can make a bigger bubble. See, you can keep blowing. The normal bubble what we make, usually are very small and then they don't stay for longer time. But this liquid soap and glycerin mixture give you, give you bigger size bubbles and they stay for longer time. See, right. So this is one way of playing. I can see many of you are playing with the bubbles. Okay, there are many ways to play this. If you have a straw, straw. Okay, if you have a straw, with straws you can make smaller size bubbles. Right, you can keep blowing. Or if you want to make hundreds of bubbles at the same time, there's one more way. Take your old socks from the cupboard, which you are not using. See, this is my son's socks. Take old socks, and then take this water bottle, where I cut the bottom out. Now put the socks over the bottle like this. Cover the bottle with the socks. I'm putting it in this bottom side. Here, cover the bottle completely and stretch it tightly so that the bottom looks like this. Got it? Okay, if you don't have the materials in your hand, don't worry, make a note of it. You can do it later. Okay, now dip this into the soap solution and then keep blowing and see what happens. You can make hundreds and thousands of bubbles in few seconds. See, they are very strong. They don't break it easily. Right? Dip it more. You need very little soap and then you can make hundreds of bubbles. Lot of fun, right? See, they don't break easily. Okay. Save this, sorry, save this liquid soap. I mean, see, I have used very little. I took a lot of soap, right? Don't pour it out. You may get scolding from mommy. Keep it, save it somewhere. Take a smaller water bottle, pour it and keep it. Whenever you want to use it, whenever you want to make bubble, you can use it again. Okay. There are many ways to play this bubble. I have even made different shapes. You know, usually you see circular objects, right, like this, and then you blow bubbles. I have made a triangle. Can we make a bubble out of this triangular shape? See, these are erasers. I cut erasers into smaller sizes, and then I took toothpick. You can use a toothpick or any other stick. You can take matchstick, and then you can just poke it inside eraser and make a triangular shape. Right? Now with this, can we make bubble? Show me thumbs up if you feel we can make bubble. Okay, I can see thumbs down. Somebody is showing thumbs down, thumbs up. Okay, I can see mixture of things. Let's see. So I'm just dipping the triangle inside the soap bubble. Let's see what happens. Still we can make bubbles. But the bubbles are not in triangular shape. The bubbles are again in sphere shape. Why? I'm using a triangular object. Still the bubbles are in sphere shape. See, I have given a square shape object with eraser. Same way eraser and sticks I used. Now let's see. Still I can make bubbles. Chat check one. See, right? Why bubbles are always in sphere shape? You know why? It's because of again surface tension. So when you mix soap in water, what happens? Okay, they're asking me from what I made. I have seen some messages in the chat box. Again, I'll repeat all the materials. In the container, I poured liquid soap and then some glycerin. If you don't have glycerin, don't worry, just use liquid soap. Only if you add more glycerin, the bubbles will stay longer. The bubbles, will become bigger and it will stay longer. If you have only liquid soap, it's fine. Still, you can make bubbles, but it won't stay longer. So these are the two things I added. Just mix it gently, and then I used sticks. These are toothpicks, 4 toothpicks, and these are erasers. Normally, what children use erasers to erase. These are erasers. So I cut the eraser into 4 or 5 parts. So I have a small, cubic shape eraser, and then I poke the sticks inside the eraser. Okay, poke it inside the eraser. So now you'll get the shape. And this is not only for bubble. Basically, if you want to teach them shapes, you can use the same method. Take a lot of erasers, cut them into smaller cubes, and then take the sticks. So if you keep 4 sticks, you'll make square. If you have 3 sticks, you'll make triangle, and then you can make 3D shapes. If you add 4 more here and 4 more here, it will become a cube. You can make cuboid, and then you can keep making it, and it will teach them a lot. You can teach them 4 sides. We used 4 sticks, so it has 4 sides. We used 4 erasers, so it has 4 corners. You can keep teaching a lot out of the shapes. Okay, so let's look at the. I think I answered her questions. Thank you. Right. So this liquid soap work with water, like a sandwich. So when you mix soap in water, the molecules form a film. The soap molecules make a layer, and above that, water molecules make a layer. Above that, again, soap molecules make a layer. So this layer creates a sphere shape because of the surface tension. Surface tension keep the sphere shape, right? So the water trapped inside soap liquid. At the top soap molecules, bottom soap molecules. In between we have water molecules. So as long as the bubble is like fine, it will keep floating. When it becomes hot, the water which trapped inside the soap liquid, I mean soap layers, will evaporate. When it becomes hot, it will evaporate. That's why the bubble just burst. Or when you poke it inside, it bursts. Right? Done. So let's make one more toy, and after that, it's 11 o'clock. I'll repeat some of the experiments, like if you want me to repeat. And after that, we'll give you 15-20 minutes. If you have any questions, you can ask us through chat box. You can type it. We'll answer you. And then if you want me to repeat any of these toys, I can repeat so you can follow it. Okay. So we have 5 more minutes. Let's do a few more experiments. Okay. So if you have a bottle at home, a simple bottle at home, you can have a lot of fun. Let me show you. Fill the bottle with water. Right. Your toy is ready. Isn't it funny? A bottle, normal bottle, and you filled water, and I'm saying this is the toy. You want to know how to play it? Call your friends, relatives, make them sit in front of you. Tell them I'm going to show you magic. Okay. Tell them to say come. So they will say come. When they say come, the water will pour like a shower. Tell them to say stop. When they say stop, the water will stop. See, I don't have any switch, no motor, nothing, just the water bottle, I'm holding it. When you say come, water will come like a fountain. See? Can you see it? When you ask them to say stop, when they say stop, it will stop. will not come. It stopped. Isn't it a magic? Looks like a magic, right? Can you play it with your friends? Easily you can play. For that, you need to ask mummy to do a small thing. Ask mummy to use a safety pin. I'm again repeating, don't use safety pins on your own. Ask mummy or papa to help you. But take a safety pin. Ask mummy to make a lot of holes at the bottom of the bottle. Right? Keep it ready. And she has to make a hole at the top of the bottle. See? I have made a hole in the cap also. So when you hold the bottle like this, look at my finger. I just covered the hole. So when the hole is covered, okay, when the hole is covered, water will not come down. When you open the hole, water will come out just like a shower. So when your friend says stop, just close your finger. Close the hole with your finger. When your friends say come, just lift your finger a little bit, and the water will keep coming. Right? This is because of air pressure. So I told you before, air is applying a pressure on everything. Here, you remember this toy with the glass we did, a glass and a card? I told you air pressure is putting pressure, air pressure is putting force on the card. That's why the card is not coming down. Same here. When the hole is covered, air pressure, air cannot go inside. There's no pressure here, but there are a lot of pressure here. That air pressure just pushes the water and stops the water from coming out of the bottle. So when I remove my finger, air pressure goes inside the hole. It pushes the water, so water keeps coming out. This is because of air pressure. Thank you. Let's do one more thing again with the bottle. Just a second, I'll clear these things. Perfect. Okay, next, again we need a bottle. Your bottle here, just a old water bottle, and then take a safety pin. Okay, someone is asking, please make it again. Sure, I'll do it again. Can I do it after this experiment? I'll do this experiment first. Okay, I'll do this experiment again. After that, I'll do that experiment. And I can see a lot of kids are doing experiment. I think they were ready with the materials and they are enjoying experiment. I can see them doing it happily. If you can take a picture of them like doing experiment and send it to us so that it will encourage us to do more sessions. Please take picture of your children doing experiment and send it to us. Okay. So this is another experiment. Take a bottle and a safety pin. At one side of the bottle, in middle of the bottle, make a small hole, and then with the help of scissor or a pencil, make the hole a little bigger. Okay, just poke it inside, keep twisting it, so the hole will become bigger. Can you see the hole now? I think you can see it. It's here. See? Okay. Now, take a straw. These are bent straws, which we used to drink juices. So you can bend it. Right. Now poke the straw inside the bottle through the hole. You get it? Simple water bottle. We have made a hole at the side, and poke the straw inside the bottle. Right. This toy will help you when you play in your garden, when you are planting plants, when you are playing in sand. This will help you. I'll tell you at the end how it will help you. Okay. Now we'll take water and fill the bottle half. So half bottle will be filled now. Okay, half bottle is filled. Perfect. So now see, this is our toy. Can you see it? A bottle, half bottle is filled with water, and there is a straw, just like a tap. Right? Now, so any pipe, tap needs some power, right? It needs some force to work. So our toy also needs some power, needs some force to work. So our power and force is going to be a balloon. Before you start this, just check your balloon. Does it have any hole? Does it have any hole? Okay, my balloon is perfect. There's no hole, right? What you have to do is just keep blowing, make the balloon bigger. Right? Now, hold the bottle and then just twist the balloon and then cover the bottle with your balloon. Right? So now the bottle is covered with the balloon. Now I'm going to open the balloon. Let's see when I open the balloon what happens. Our toy is going to work now. Be ready? See? This is like a tap. When you're playing in the garden, when you want to wash your hands, keep this simple setup in your garden. After you played, just open the balloon and then you can wash hands. It will work like a tap. Right? This works again with the help of air pressure. There's a lot of air in the balloon, right? And here you have water. When you open the balloon, this pressured air will try to go inside the bottle. When the air goes inside, it pushes the water. That air pressure raise the water level in the straw, so the water keeps coming, keeps coming, keeps coming out. Right? Did you enjoy it? This is due to the air pressure. Okay, kids have started answering also. I've seen some kids said it's because of air pressure. Very good. Found it. You understand? Okay, if you don't have straw and balloon, don't worry. Keep a note. And we are also going to send you, a file, a document which will have few experiments which you can try at home. At the end of this session, we will upload that file in chat box. Just before you leave the meeting, go to chat box and click the document. You'll be able to download it. Download the document. It has a lot of experiments. You can try it at home till the time we meet next time. Okay, right. So we made a lot of toys. At the beginning, we made a straw flute, right? I said it works because of vibration. And then we made a small toy which again created noise with balloon and sketch pen I made. I said that also works with the help of air pressure, and that works because of vibration. Then we made a paper cone and blow the straw inside the cone. When we blow, the sound became louder. I said that is because of amplitude of sound. And then we took a magic glass and a card. When we turned it upside down, the card didn't fall down. I said it's because of air pressure. And then we took again a glass and then covered the glass with net and then turned the glass upside down. I said water didn't come down because of air pressure and surface tension. Then we put a lot of coins inside a glass of water. The water didn't overflow till we put the seventh coin, eighth coin. I said the water didn't overflow because it is because of like surface tension. And then we tried this balloon pump. This is also because of air pressure, right? And then we made bubbles. That is because of surface tension. I said, okay, these are the things we did today. I purposely wanted to do this experiment with household materials because you can try all these things at home. So we may do these kind of sessions in future. In future also we'll do these kind of experiments where you can use household materials and try all these things. And this is for all age group people. A 3-year-old child can play this. A 75-year-old uncle and auntie can play this. It's fun, pure fun. Plus you can learn a lot of science. Okay. So whatever I showed, it is like, my idea. I mean, I saw it somewhere and then I found these materials in my house. So I use these materials. If you don't have these materials in your house, try to use different materials for the same experiment. That will teach you real science. When you try something on your own, you find more than somebody is teaching you. Okay. Use different materials to do these experiments and mail us. Like we are going to show you our mail ID. Mail us what happened. Could you do all this experiment? Did you use different materials? Did it work? So all those things you can mail us. And please send us your photos, like your child photo where he's doing experiments. It'll be a great help. Thank you so much. Now, if you want me to repeat any of the experiments, I can repeat. Or if you have any question, you can ask me. I'll be ready to answer. Okay, let's go ahead. Any questions? You can start writing in chat box. Or if you want me to repeat any of the experiments, I can repeat. We still have 15 minutes more. Please repeat the forest straw experiment. Okay, very interesting. Thank you so much. Thank you for your appreciations. If you have any question, I can answer you. Thank you so much for cooperating and listening carefully. Thank you. Thank you so much. Are there any questions? I'll be happy to answer. Thank you so much. Okay, so now we have uploaded the file. We have uploaded the file. You all can download it from chat. Go to chat and you can see a document there. Please download it. There are a lot of experiments there. You can download it and then do it at home. Same, I have listed out some materials in the experiment list. Don't just follow the same materials. Try to use different materials that will teach you a lot of science. And please write to us, like send a mail to us, like I have tried this experiment in this way. I use this material, still it works. Write your experience to us, and we'll be really happy to see them. And we will repeat them in our next sessions. Right. Okay. Are there any questions? Still reading it. Okay. Can you repeat the fan experiment? I'll repeat. Okay. So fan experiment had two straws. See, one smaller straw and one little bigger straw, bigger than this. And then I cut the straw into 4 pieces. See, I divided the straw into 2 parts. The bottom part is a little longer. The top one is a little shorter. I cut the top one into 4 parts. Like 1, 2, 3, 4. And then all 4 should be equally divided. Now just press them so they will look like a fan. You know, they are petals of flower and like a fan. Right? Now just twist them a little bit to your right hand side. Very little, huh? Don't break it. Very little. Turn very little. Ready. Now take the smaller one. Just poke the bigger one into the smaller one. And I have attached a safety pin so that it will hold the straw. If you don't have a safety pin, you can give your thumb to support it. See, like this. Right? Now your thing is ready, and this thing is just extra so that it will become strong. So this is fine. Now, if you blow it, it will work like windmill. You can blow it, or if you have a fan at home working, you can just place the thing under the fan. It will keep spinning. Make 5, 6, and then place it on your table. See how people are surprised. Okay, someone is asking. I think you got it. Thank you so much for asking it again. Someone is asking, can you use oil? I never tried oil in my bubble, solution. But the one which you get it from outside, they mixes a lot of things. They mix kerosene, soap liquid, and I heard they mix oil also. Not the coconut oil which we use it at home. They make some kind of oil. But in my soap solution, I don't mix oil. I mix glycerin and soap. That is enough for me. I mean, you can make a lot of bubbles, and you can store it for a longer time. If you keep the solution for 1 day to settle, on the second day you can make really big bubbles. Because of the screen, I made smaller bubbles. Otherwise, you can even make bubbles like pumpkin. Okay. Thank you. Straw fan. Okay, I did it already. Repeat straw fan. Many of you are asking straw fan. I think you got it second time. Okay. I couldn't. Someone is asking, not able to see document. Go to your chat. Go to your chat box, and we are keep uploading it again and again. And there's a download button. Just click download. You will be able to get it. Okay. Thank you for all the appreciations. Okay, someone is asking repeat the straw experiment. Okay, again I'm showing this is very simple. Take a straw, cut one end in V shape, just like this. To make it clear, I'm making it with a bigger straw. You can see the cut clearly. Only because of that I'm making it. See now, can you see it clearly? I think on my t-shirt you can see clearly. Or I can hold it even closer. Can you see it clearly? This is the way you have to cut and then press it. I'll try it, may or may not work because the straw is really thick. Oh, it still makes noise. The only problem is my lips vibrate a lot. I can't blow it this way. And you need a lot of energy because the hole is bigger. A lot of air will escape. You need really bigger lungs to do this. Still, it works. But the cut is same. If you use a smaller straw, it will be more, easier for children to blow it. So what? Before you start, just press the tip a little bit and then blow. It's very simple. But you need practice. Try it 2-3 times and then you'll get it. Okay. Chat buddy, okay. Actually, the document is sent it to everyone. It's not only to admin. I can see your question. It is sent to everyone. So we keep repeating the document. You can download it. Okay, we are sharing it again and again. You get it. Okay, some parent downloaded and he's also uploading it again. Okay. Someone is saying, sir, I made a paper fan. Very good. Keep doing it. Okay. Thank you so much. Before I leave, I'll show you one more toy because some people are still trying to download the file. We'll give some time to download it. Till the time, I'll show you one more experiment. Try this at home. And then by the time everyone download it, we can use it. Okay. So this is a very, very simple experiment. Just with a paper. See, I made a joker out of paper. Right. You can draw it, or in the attached file, if you download it, this template is given in the same attachment. When you print that attachment, you will get this joker. Okay. Cut this joker out, and then I have made a stand with a stick. See, I have a stick, and then I poke the stick inside an eraser. So this will work like a stand. See, just like this. This. Okay, perfect. So see, this joker has raised his hand, right? So he is going to try. He is going to. Yes, people are trying. So just try to place the joker on the stick. Can he balance? I don't think so. It's really, really difficult for him to balance because the stick is very thin, right? So what to do? How to make him balance? He wants to show you a trick. He wants to show you how to balance on a stick, but looks very difficult, right? So let's help him. Have you seen people walking on ropes? Have you seen them walking on ropes? Yeah. What do? When they walk on rope, they carry a stick with them, right? They carry a stick with them, hold it, and then they walk on rope. If you see, most of the time their hands are like trying to balance the stick. Or like children from lumens, you all walk on balance beam, right? So initially, the first day when you try to walk on balance beam, what did you do? You try to keep your hands like this, right? Why? Because you wanted to balance. You didn't understand the balance, so you kept your hand to right and left. Whenever you were going towards right, you keep your left hand side to support you, or to the left when you went, you kept the right hand side to support you. Same way, I'm going to support this joker with safety pins. Take two safety pins. I'm going to attach this safety pin with his hands, just like this, right? And then one more safety pin to the other hand. Ready. Now, just like a stick, when people walk on the rope, just like you holding hands and walk on beam, I have given two weights to the joker to balance himself. Now, let's see what he does. See, he's balancing on the stick. He's not falling. I can even move him. He can move, but he's not falling. It's very, very simple, but when you look at it, it looks like some miracle. Just a paper but balancing on a small stick. This is because of center of gravity, right? This head always, center of gravity goes in the middle of any object. Like if you're standing, the center of gravity goes in the middle of you. So if you lean toward, ahead, or if you are going backwards, when your center of gravity goes out of your feet, then you fall, right? Always the center of gravity should go on the object. I mean, the base of the object. Here, the joker, I added weight. The joker is tilted, right? So here, center of gravity is going on the stick. But left hand side, his body is balancing. Right hand side, the pin is balancing. That's why he's on the stick, right? See, you can even spin. Sorry. So when you add equal weight to both the sides, this joker can balance because center of gravity still goes on the stick. His body balance the weight to the right and left, right? That is why he's like on the stick. This picture, you will get it in your document. Please download it. You'll find this template there. You can just print it and start using it. Okay, please enjoy all the experiments. Please write it to us. And take picture of your child and send it to us. It will be helpful. And I know you all are a little upset because of the lockdown. Now you are not going to the beaches, theaters, playground. You are at home. Don't feel bad. Take it positive. I know people are suffering because of this corona and lockdown. Let's pray for them. On the other side, you don't feel bad. Take it in a positive way. This lockdown teaches us a lot of new things. Fathers are learning cooking, mothers are learning computer. You are learning a lot of new things, helping parents. You know, and it create a new atmosphere for education. Like we are using technology to learn something. So we all are trying a lot of things every day. So it gave us an opportunity. I mean, it is giving us an opportunity to learn different things. So keep learning, keep enjoying things, and we will try to come again and show you a few more things. Let's meet on another day. Thank you so much for being here and enjoying the experiments. See you on some other day. We'll inform you soon. Thank you so much. Bye bye. So I'm going to keep this. We are not going to leave the meeting. People who are done, you can leave the meeting. Thank you so much. We'll see you again. People who are still downloading the file, please be on the line, download it and then leave it. We are not going to end this meeting. It will be there for some more minutes. You can download the file and leave. Thank you so much. Bye bye.